Hello, everyone. My name is Paul Mokotoff, and I am from the Integrated Design of Environmentally Friendly Aerospace Systems Laboratory, or IDEAS Lab, at the University of Michigan, directed by Dr. Gokchin Shinar. You can find us at ideas.engine.umich.edu. Today, I will be introducing you to our open-source software known as the Future Aircraft Sizing Tool, or FAST. And in today's tutorial, I'll provide an introduction to FAST. We'll talk about what the tool is capable of doing, a simple workflow embedded in the tool, and then we'll also talk about some upcoming tutorials that you can expect to see. Before we continue on, I would like to thank the NASA Aeronautics Research Mission Directorate and the Electrified Powertrain Flight Demonstration, or EPFD project, for sponsoring this work. FAST was developed under the project Development of a Parametrically Driven Electrified Aircraft Design and Optimization Tool. Additionally, the Ideas Lab would like to thank Ralph Jansen, Andrew Mead, Karen Bozak, Amy Ciccatelli, Noah Listgarten, Dennis Rohn, and Gaudy Bezos O'Connor from the NASA EPFD project for supporting this work and providing valuable technical input and feedback throughout the duration of the project. And without further ado, let's go on to see what FAST can do. So with minimal information, FAST rapidly sizes an aircraft for any propulsion system architecture. So at a minimum, the user needs to provide these 5 inputs: the entry into service year, the number of passengers to be carried or a payload, the design range, the propulsion architecture, and the aircraft class, such as turbofan, turboprop, or piston aircraft, along with a design mission profile. Using this information, FAST will leverage physics-based models and embedded historical aircraft and engine databases during sizing to create an aircraft concept. Once the aircraft is sized, the user can see multiple outputs, such as a geometry, a weight breakdown, and a full mission history for the design mission that the user specified. Since FAST rapidly sizes aircraft, it is a perfect tool for design space exploration and early phase conceptual design studies. Now that we've taken a look at what FAST can do, let's briefly look at the workflow embedded within FAST. So earlier I mentioned that the user provides some inputs as well as a design mission profile, and those are specified in these 2 boxes here, with the top-level aircraft requirements and the design mission profile. Once the user prescribes these, FAST will incorporate those into an aircraft model, which serves as an initial guess for the sizing. Then there is an iteration between the aircraft sizing and mission analysis until the design closes. In the aircraft sizing portion, we are mainly focused on sizing the wings and engine to determine an operational empty weight for the aircraft. And then in the mission analysis, we will fly the design mission profile that the user provides to figure out how much fuel or battery or any other energy source that the aircraft needs to carry. If you are providing a propulsion architecture that is electrified, you'll also have to provide us with a power management strategy, which describes how the electrified portions of the powertrain are used as a function of the flight segments. This process will iterate until the design converges, giving you a sized aircraft that you can then visualize, look at the weight breakdown, or explore the mission history with. Now that we've gone through a quick look at FAST, let's talk about some of the upcoming tutorials you'll expect to see. First, we'll go through how to download FAST from GitHub. Then we'll go through how to size an aircraft using some of the pre-packaged aircraft that are shipped with FAST. After you know how to use FAST, we'll work on developing parametric aircraft models and mission profiles so you can use FAST for your aircraft design needs. Then we will work on creating novel propulsion architectures. That way you don't only have to rely on the ones that are shipped with FAST. And then lastly, I'll turn it over to a colleague to talk about how to visualize aircraft concepts. Not only can you visualize the outer mold line of the aircraft concept, you can also visualize schematics of the propulsion architecture. And right now, FAST is shipped with a bunch of geometries to help you visualize aircraft more quickly, but we will also go through how to create your own geometries so you can visualize your own aircraft designs. So with that, we would like to thank you for joining us on this journey to learn more about FAST. Make sure to check out the Ideas Lab website at ideas.engine.umich.edu and make sure to download FAST from GitHub at the link below. Thank you for watching, and we'll see you at a later tutorial.